Hello everyone, welcome back to lecture 6 of kinematics. In this particular lecture, I will be teaching you how to derive equation of motion and will solve some question based on that. I hope you are familiar with these three equations from your class 9th standard. V equal to u plus at, s is equal to ud plus half at square and v square is equal to u square plus 2as. Today with the help of calculus, I will show you how we can derive those equations. Okay. So start with the first equation. I hope you all know the first equation is V is equal to U plus AT. Okay. So let's say we are having a particle at time t equal to 0. Initially, the particle starts with a velocity of u meter per second. So what is u? U is the initial velocity when time is 0 initially. Okay. Now a force acts on a particle, or you can say an acceleration acts on the particle in the same direction. A is what? Acceleration, and this acceleration is constant. I hope you all know the equation of motion can be used only when acceleration is what? Constant. So this acceleration is constant. So we have a particle when time is 0, the velocity of the particle is u. On that particle, a constant acceleration a is acting. Okay, and after t time, when time t equal to t, now what this acceleration will do? We know acceleration is rate of change of velocity. Due to acceleration, velocity will change. So after t time, let's say the velocity is v. Okay, after t time, let's say velocity is v. So I hope you all know that acceleration is defined as rate of change of velocity, which is dv by dt. Is it? What is acceleration? dv by dt. So from here, can I write dv is equal to a dt? Correct? If I integrate both the sides, acceleration is constant, it will come out of integration and you will write dv is equal to a integration dt. Correct? Now here we have velocity, here we have time. So when you put the limits, lower limit of time is what? Initially time is 0. And when time is 0, for velocity, what is the lower limit? The initial velocity is u. You will write here u. Then at this moment, time is what? T. And velocity is what? V. Correct? Integration of dv will be what? You will say, sir, integration of dv will be v. Yes or no? Integration of dx is what? X. In the same way, integration of dv will be v. Upper limit v, lower limit u is equal to, acceleration is constant, integration of dt will be what? T, limit from 0 to t. Put the upper limit v minus lower limit u is equal to a, upper limit t, lower limit 0 minus 0. So from here you will get v minus u is equal to at, which I can write as what? V equal to u plus at. This is first equation of motion. V equal to u plus at. To be more precise, see, one thing you all have to take care. In v equal to u plus at, what is v? V is the velocity at an instant, or you can say final velocity. Velocity at an instant or final velocity. Final velocity. What is u? U is initial velocity. Okay, initial velocity. What is a? A is acceleration. And what is t? Time. You can see velocity, acceleration. So it's an equation which contains vectors. So while solving, you have to be very careful with sign, with direction. To be more precise, I can write this equation as vector v is equal to vector u plus vector a into t. But right now we are doing motion in one dimension, so you can remember v equal to u plus at, that is sufficient. But you have to be careful while putting the value. You have to make a sign convention. Okay. For our lecture, I will be taking right as positive, left as negative, up as positive, down as negative. If you want, you can take right negative, left positive. Depends on you. But generally we take this sign convention. This is what I'm going to follow. Whatever you take, ultimately we will reach to same answer. No need to worry. But you follow this. Whatever is in right direction, take positive. Left direction, negative. Up, positive. Down, negative. This is the actual format. Vector v equal to vector u plus vector a into t. Okay. But for one dimension motion, you can just remember v equal to u plus at. Clear? So what I have done, at time t equal to 0, a particle starts with initial velocity u. A force or an acceleration acts on the particle. Due to acceleration, velocity of the particle change. After t time, velocity is v. We know acceleration is dv by dt. dv is a dt. Integration, we will integrate both the sides to find the change in velocity, or to find velocity. If you integrate both the sides, acceleration is constant. It will come out of integration. dv equal to a dt. Integrate. Initial time was 0. Initial velocity was u. Final time is t. Final velocity is v. I just integrated, got the answer. But keep in mind, the equation will hold only when acceleration is constant, because the acceleration came out of integration. If acceleration is variable, then what you will do? Let's say acceleration is t square. Some alpha t square. Alpha is a constant. Acceleration is alpha t square. In place of acceleration, you will put what? Alpha t square, and you will integrate. So when acceleration is variable, we will integrate. We will put the function of acceleration, whatever they have given, and we will do integration. I think this is what we have done in the previous 4-5 lectures. Clear? But when acceleration is constant, you can directly use v equal to u plus at. Clear? All of you pause and write. Pause and write. Done? Okay. Let's move on to second equation of motion. Second equation of motion, which is s is equal to ut plus half at square. Okay. Let's say we have a particle at time t equal to 0. Initially, particle has a velocity u meter per second, and the position of the particle is ri. What is ri? Initial position of the particle. A constant acceleration acts on the particle. Due to which, after some time, the velocity of the particle will be v. Acceleration means what? Change in velocity. Velocity has changed to v, and the particle has displaced. So this is the final position of the particle, rf. And while going from here to here, this is the displacement of the particle, s. What is displacement? Final position minus initial position. Yes or no? Displacement is final position minus initial position. All these things we have discussed. Yes or no? Okay. So now, as we know, velocity is rate of change of position. Velocity is dx by dt. Velocity at an instant is rate of change of position of the particle. Okay. So from here, the small change in position I can write as what? v dt. Correct? To find out position or to find out displacement, we will integrate. Correct? Now, this v, I can write this v as what? If you see, just now we got v equal to u plus at. So in place of this v, you can write integration of dx is equal to, in place of v, you can write u plus at dt. Correct? Okay. Now, what are the limits? Here we are integrating with respect to time, So what is the lower limit of time? 0. And when time is 0, this we are integrating what? This is position, change in position, dx, a small change in position. So when the time is 0, what will be the lower limit of this? The particle starts at ri. Correct? And when time is t, particle is at rf. ri is the initial position, rf is the final position. Integration of dx will be x, which is equal to, this you can write as integration, if you open the bracket, u dt plus integration at dt. From where to where? 0 to t, 0 to t. So integration of u dt, u is the initial velocity, it is constant, u will come out. Integration of dt will be t. Correct? Limits from 0 to t. Here limits from initial position to final position, plus acceleration is constant. If acceleration is constant, it will come out of integration, and we have t dt. So integration of t dt will be, this is t power 1. So t power 1 plus 1 divided by 1 plus 1. So t power 2 by 2 from 0 to t. Correct? Now put the limits and what you will be getting, upper limit final position minus lower limit initial position is equal to upper limit t, lower limit 0, t minus 0 t plus 1 by 2a, so half a, upper limit t square, lower limit 0 square, so t square. And what is r final minus r initial? Just now I told you final position minus initial position is what? Displacement. This is your what? Displacement. So displacement is equal to ut plus half at square. Is it clear to everyone? To be more specific, you can write vector s is equal to ut plus half acceleration vector into t square. But all these things will be required now when I will be teaching you 2-dimension or 3-dimension motion. Okay, right now for 1 dimension you can just remember s is equal to ut plus half at square. But one thing you have to be very careful, again the sign convention. Whatever is in right, positive, whatever is in left, negative, whatever is up, positive, whatever is down, negative. No need to worry, we'll solve questions, you will understand. Clear? So what I have done here, the particle starts when time is 0, initial velocity is u and position is ri. And due to acceleration, after some time, the position is rf, velocity is v. After t time. After t time. Okay? So we know particle went from here to here. So the final position is rf, initial is ri. So final position minus initial position will be what? Displacement. Correct? We know velocity is dx by dt, rate of change of position. So dx will be v dt. Integrate both the sides. When time is 0, position is ri. When time is t, position is rf. When you integrate dx, you will get x. You integrate, put the limits, you will get final position minus initial position is equal to ut plus half at square. This change in position is known as what? Displacement. Clear? Understood? Okay, all of you pause and write. Pause and write. Done? Okay. Now we'll move to third equation of motion, which is v square is equal to u square plus 2as. A equation which tells us the relation between velocity at a moment with displacement of the particle. Okay. So in this case, we are having a particle at time t equal to 0. Here there is no time. Okay. So no need to write time. You can just write initial velocity of the particle is u. An acceleration act on the particle. Acceleration is constant, and the position of the particle is ri. Because of acceleration, what will happen? Velocity will change. So after some time, the velocity of the particle is v, and the position is rf, and this is your what? Displacement. This is what? Displacement, rf minus ri, or the amount by which the particle has displaced. Clear? Okay. Now I want to relate velocity with displacement. Correct? Okay. I know velocity is dx by dt. Yes or no? Yes, sir. So what you can do is, and also we know one thing, that acceleration is dv by dt. Acceleration is dv by dt. Correct? You do one thing. In this, you multiply by dx and divide by dx. Before also I have told you this. Now what will be this dx by dt? Velocity. So acceleration will be what? Dx by dt will be velocity into dv by dx into dv by dx. Correct? I will use this equation. I will use that equation. It can give me a relation between velocity and displacement, and there is no time involved. Correct? Okay. So you can write, sir, acceleration is v dv by dx. So we can write from here v dv is equal to, send dx on that side, a dx. Correct? Again, integrate. Now, initial velocity of the particle is u, so lower limit u. At that moment, position of the particle is ri. Final velocity of the particle is v. At that moment, the position of the particle is rf. Correct? Okay. Now, what I can write? v dv, integration of v dv, v power 1 plus 1 upon 1 plus 1, v square by 2. Limits from where to where? U to V is equal to, acceleration is constant, it will come out of integration. Integration dx will be x, limits from r initial to r final. So what you will be getting, put the upper limit v square by 2 minus put the lower limit u square by 2 is equal to a into put the upper limit r final minus put the lower limit r initial. And what is r final minus r initial? R final minus r initial is nothing but displacement of the particle. So you will be getting v square minus u square by 2, send 2 on that side, is equal to 2as. Therefore you are getting v square is equal to u square plus 2as. This is the third equation of motion. Correct? You can do one more thing. I can give you one more method, one simple method. You can try. You know S is equal to ut plus half at square. S is equal to ut plus half at square. And the first equation was v equal to u plus at. So from here what will be t? V minus u by a will be t. If this value of t you take and this value of t you put here, and here you will be getting v square is equal to u square plus 2as. Same thing you will get. You can use this method also. I want you all to try this by yourself. Clear? And again, to be more specific, you can write this as vector v mod square is equal to vector u mod square plus 2 a dot s. This is the actual format. Again, I am saying this will be required when I will be dealing 2-dimension motion or 3-dimension motion. Right now for 1 dimension, you all keep in mind v square equal to u square plus 2as. Clear? Understood? Pause and write. Pause and write. So what I have done here, I want a relation between velocity and displacement. So I know acceleration is dv by dt, multiply by dx, divide by dx. This dx by dt will be velocity. So acceleration is v dv by dx. I wrote v dv together and I sent dx here, a dx. I put the limits, I integrated, I got v square equal to u square plus 2as. All of you can pause and write. Done? Okay. Now I want you all to remember few points. Like in v equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. And what mistakes you can do, I want you all to keep those things in mind. V is final velocity. V is what? Final velocity, correct? U is what? Initial velocity, fine. Initial velocity. What is A? Acceleration. And this acceleration has to be constant. This equation came when I assumed acceleration to be constant. If it's not, again we will go to fundamentals, that is integration. Okay, and S is very important, as is displacement of the particle, not distance. It's not distance, keep in mind, displacement. Clear? And you have to take care of sign. Write this also. Take care of sign. Take care of sign. Right parameters we will take positive, left parameters we will take negative. Up we will take positive, down we will take what? Negative. Now I want you all to remember one more thing. You know, in place of this u, from the first equation, what is u? From the first equation I can say v u equal to v minus at. So s is equal to, in place of u, if you put v minus at into t plus half at square, you will get s is equal to vt minus half at square. You can check. S is equal to vt minus half at square. Remember this also. This will save your time. Otherwise, some questions will be there in which you have to use first equation, then you have to go for the second equation to get the answer. But if you remember this will save your time. S is equal to ut plus half at square is same as S is equal to vt minus half at square. Very important, time saver. Clear? All of you pause and write. Pause and write. Done? Okay. Let's solve some problems. Okay. We'll start with a very simple problem. Okay. We have a particle and this particle is moving in x direction. The initial speed of the particle is 5 meter per second and the acceleration acting on the particle is in right direction. That is also acceleration is right and the value of acceleration is 2 meter per second square. Find velocity at 3 second and second displacement in 3 second. Displacement in 3 second. All of you pause and try. Okay. See, always use check what is given and what you are finding. Accordingly, you can pick which equation you have to use. Like in the first problem, first you write what is given. Initial velocity is right. Right is positive. You write on the top. We will take right positive. Whatever is left, we will take negative. So you write u equal to 5. Right means positive. Acceleration right 2 meter per second square positive. Correct? In the first question, I want V. So U I know, A I know, time is 3 seconds. I want V. So which equation? First equation because it contains V, U, A, T. So you will use V equal to U plus AT. So V is the final velocity, U is the initial velocity 5 plus acceleration of the particle is 2 and I'm asking velocity after 3 seconds, put here 3. Velocity will be 11 meter per second. So after 3 seconds, the velocity of the particle will be 11 meter per second. Positive answer came, it means particle will be going right. Correct? Second part, displacement in 3 seconds. Displacement is given, displacement they are asking, time is given. Which equation has displacement and time? Second equation. Third has VUSA. There is no time in the third equation. In the second equation, we have displacement as well as time. So I will use the second equation. S is equal to ut plus half at square. Correct? So S will be ut. What is u? Initial velocity 5. After what? 3 second plus half. What is acceleration? 2. And what is time? 3 square. So what you will get? 15 plus 3 3 is a 9. 24 meter will be displacement. Positive you got, it means particle has been right, and it's obvious the particle will go right because velocity is right as well as acceleration is right. Clear? Understood? And I hope you are understanding what is the meaning of acceleration. We have discussed. Yes or no? 2 meter per second square, which means 2 meter per second per second. It means this acceleration is changing the velocity by 2 meter per second every second. That's why after 3 seconds what happened? Well, particle is going with 5. After 1 second velocity will change by 2, it will become 7. After 2 seconds again change by 2, it will become 9. And again after 1 more second, total 3 seconds, again it will increase by 2, and from 9 if it increase by 2, it will become what? 11. That's why we got 11 meter per second. Every second velocity is increasing by 2 meter per second. I hope it is clear to everyone. Okay, it was a very basic question. Copy fast, we'll move to next part. Done? Okay. Question number 2. Again, we have a particle at time t equal to 0. The velocity of the particle is, that is initial velocity is 10 meter per second and acceleration on the particle is 2 meter per second square in left direction. Okay, you have to find first part velocity after 3 second, velocity after 3 second, you can write like this. Second part displacement after 3 second. Third part displacement after 8 second. Fourth part, S means displacement. Fourth part distance covered after 6 seconds. I want you all to pause and try all the parts. Pause and try. Done? Done? Okay. So let's solve with the first part. I have told you take care of sign. Very, very important. First you write what is given. Initial velocity 10. Right means positive. So plus 10 meter per second. Acceleration is left. So you will take acceleration as what? 2 or minus 2? Minus 2 meter per second square. Correct? In the first part what they are asking? Velocity at 3 seconds. So what you will do? First part, velocity at 3 seconds. So I will apply v equal to u plus at. So v I want to know. Initial velocity is 10. Acceleration will be minus 2. After what time? 3 seconds. So velocity will come 4 meter per second. Positive means the particle will be going right only. I think you can visualize this motion. Can I say it's something like, if I throw this marker up, I have thrown the marker up. If I throw the marker up, gravity is down. So velocity up, gravity down, acceleration down. Velocity right, acceleration left. Velocity up, gravity or acceleration down. So what will happen? First the particle will slow down, come to rest, then particle will come down. Or you can feel like this, a particle is going right, acceleration left means force left. Force is equal to mass into acceleration. It means force is opposing the motion. So first particle will slow down, then particle will go back. This force is pulling the particle back. Particle is going right, inertia is there, velocity is in right direction. Or your left, right now left. So velocity is in left, but the force is in right. So first force will slow down the particle, bring the particle to rest, and then pull it in its direction. And then particle will slow down, and then particle will go back. That's why if you see, velocity came 4. Particle started with 10, but after 3 seconds velocity is 4. It means particle is slowing down. Clear? You can add one more thing. Find velocity at 7 seconds. You can check. Find velocity at 7 seconds. What you will get at 7 seconds? So velocity at 7 seconds will be u. What is the initial velocity? 10 minus what is acceleration? 2 minus 2 and time is 7. So minus 4 you got. What is the meaning of minus 4? The particle is going back. The particle is going in left direction because velocity came negative. I hope it is clear to everyone. Okay. Now let's do the second part. What is second part? Displacement in 3 seconds. Displacement in 3 seconds. So this I will use what? Time is given, displacement I want, s is equal to ut plus half at square. S is equal to ut plus half at square. So what you will get? U. What is the initial velocity? 10. In what time? 3 seconds. Plus half. What is acceleration of the particle? Minus 2. Time is what? 3 seconds. 3 square. So what you will get? 30. This will be minus 3 square 9. 21 meter will be displacement of the particle. Understood? Second question, second part, displacement in 8 seconds. Again ut, u is 10, time is 8 plus half, acceleration is minus 2 and time is 8 square, ut plus half 8 square. So 80 minus 64, 16 meter. Displacement is what? 16 meter. In both the case, displacement is positive. It means right now the particle is on the right side. If displacement comes negative, the particle is on the left of the initial position. So whenever you get an answer, think on that. What can be the position of the particle? What can be the direction of the particle in which the particle is moving? Take care of these parameters also. Okay, this will make your concept strong. Now fourth part, important. In the fourth part, I have asked distance covered after 6 seconds. Don't use s is equal to ut plus half at square and put time t equal to 6 seconds and you will get distance. No. This s is the displacement of the particle. This will give you displacement, how much the particle has displaced from the initial position. This will not give you the actual path covered. Now you will say, but sir, sometimes distance and displacement are same. Yes. Multiple times I have told you in the previous lectures, if a particle is going in only one direction, either left or right, distance and displacement will be same. Then for distance, you can use this equation, no problem. But I have told you, whenever the particle change its path, whenever particle change direction in 1D motion, distance and displacement will not be equal. And I hope you understood in this question what is happening. That's why I explained that part. First the particle will slow down, come to rest, then particle will go left. It means distance and displacement will be different. Distance will be more. It is the actual path covered. But displacement is the shortest path. If I throw this pen up, it will go up, then it will come down. Same type of motion. It will go right, then it will go left. In this case, distance and displacement will be different. And I have told you how to solve this type of questions. Always find out that time when the particle velocity is zero. Because if the particle is changing direction, for a moment its velocity will be becoming what? Zero. So how to solve the fourth part? First you check when the velocity is zero. So we know v equal to u plus at. Fine. So v equal to, what is u? You will say, sir, u is 10. What is acceleration? Minus 2. Time, let's say t. And put velocity 0. Put the value of v0. If you put v0, this v0, you will get the time when the velocity is becoming 0. So 0 equal to 10 minus 2t, 2t equal to 10, therefore t equal to 5 second. It means at 5 second, the particle is coming to rest for a moment and changing its direction. At 5 second, the particle is coming to rest for a moment and changing its direction. So what I will be doing, I want distance covered in what? In 6 seconds. So particle starts from here. That particle which I have drawn, let's say the particle starts from here. At 5 seconds, the particle comes to rest for a moment and then the particle changes direction. So let's find out how much the particle has displaced in 5 seconds. So displacement in 5 seconds will be, you will say ut plus half at square. Initial velocity is 10, time is 5 plus half. What is acceleration of the particle? Minus 2 into 5 square. So what you will get? 50 minus 25, 25. So when particle is here, when velocity is 0 at 5 seconds, the displacement is 25 meter. Correct? Then you find what is the displacement in 6 seconds. I will tell you why I am finding that. First you find displacement in 6 seconds. ut, u is 10, time is 6 plus half, acceleration is minus 2 into t square, 6 square. So what you will get? 60 minus 36, you will get 24 meter. Is it correct? 60, yeah, minus 36, 24 meter you will get. It means now from here, this is at 5 seconds. This is at t equal to 5 seconds. Let me write with a different color pen. Okay, so at 5 seconds the displacement is 25 meter. At 6 seconds the displacement is 24 meter. It means at 6 seconds the displacement of the particle from here is 24 meter. Are you understanding what is happening? Listen very carefully. Listen carefully. At 5 seconds the displacement, initial position, we tell displacement from where? From initial position. From initial position displacement is how much? 25 meter. And at 6 seconds, this is at 5 seconds, and this is the position at 6 seconds. Why I went left? Because position is 24 meter. It has reduced, displacement has reduced. So from here, this is 24 meter. So how much particle has traveled? You will say, sir, particle went from here till here in 5 seconds and particle covered 25 meter. Then particle came back by 1 meter. So displacement is 24 in 6 seconds, but distance in 6 seconds will be 26 meter. I hope you all understood. Why 26 meter? Because at 5 seconds the velocity of the particle is becoming 0 and displacement of the particle is 25 meter. And after that, in 6 seconds, displacement of the particle is showing 24 meter. It means now the particle is 24 meter away from the initial point. So at 5 seconds the particle was 25 meter away. At 6 seconds the particle is 24 meter away. So how much the particle has traveled in reality? 25 till 5 seconds and then came back 1. So 1 meter. Then only the displacement will be 24 na. So 25 plus 1, 26 meter will be the distance covered. I hope you understood. You can do one more thing. Here to here you got distance 25 meter. Now from here to here, again you can apply S equal to ut plus half at square. At this moment you take velocity 0, so u will be 0, half, acceleration will be 2 into, from here to here time will be what? 5 to 6 seconds, 1 second. So half, acceleration will be minus 2 into 1 second. Or you can take acceleration, okay, minus 2 you take, no issue. You will get 1 by 2 into 2 into 1, that will be 1 meter. So 25 plus 1, 26. I am not solving with that way. I want you all to try if you want. This is the answer. Understood? Clear? So whenever the particle comes to rest, you have to keep in mind distance and displacement will be different. To find out distance, what you have to do, you have to check when the particle comes to rest. In this particular question, particle comes to rest at 5 seconds. So at 5 seconds, I have calculated displacement of the particle. I got 25 meter. It means from the initial position, the particle is 25 meter away. Correct? Then I checked at 6 seconds. At 6 seconds, displacement came 24 meter. It means from the initial position, particle is 24 meter away. It means particle is somewhere here. From the initial position, particle is 24 meter away. It means particle has returned back by 1 meter. So distance cover will be 25, 126. And what is second method? You find displacement in 6 second, sorry 5 second, 25 meter, then displacement in this 1 second, and add them. Don't take minus. When you are finding distance, you have to add everything because distance can never be negative. So first 5 second, and then from 5 to 6 you have 1 second. Apply formula in that, you will get the same answer. I hope it is clear to everyone. Understood? Try. Okay, let's move on to next problem. In next problem, a car is moving with a velocity of 100 meter per second. Okay, car was going with a velocity of 100 meter per second. Suddenly, the driver sees an obstacle in the path. Driver sees an what? Obstacle in the path, and he applies brake. Driver applies brake. Clear? And the car comes to rest. Car comes to rest after traveling 400 meter. You have to find out first part acceleration, second part retardation, and third part time in which car came to rest. Car came to rest. All of you pause and try all the three parts. The car was going with 100 meter per second. Suddenly driver sees some obstacle in the path and he applies brake. After applying brake, the car takes, see, if you apply brake, your vehicle does not come to rest immediately. It travels through some distance. So the car has traveled 400 meter and then car has came to rest. So you have to find out what acceleration, retardation the brakes has given to car, and what will be the time in which the car will come to rest. All of you pause and try. Done? Okay. So if you look at this particular problem, the car was having initial velocity 100. Correct? When the brakes are applied, brake will give you what? A retardating force? Yes or no? Or a negative acceleration? We can say that. So the brakes will give what? A force in opposite direction to the car. Acceleration in opposite direction. Then only the particle will slow down. Okay. And finally the car comes to rest. Finally our car came to rest. So when the car comes to rest, final velocity will be 0. So the initial velocity of the car is 100 meter per second. Final velocity of the car is 0. And the displacement from here to here, right, displacement is right, displacement of the car is 400 meter. First part they are asking acceleration. Time is not given. I have u, v, displacement. Second and third equation has displacement. Second has time. Third don't have time. Here we don't have time, so we will use third equation. V square equal to u square plus 2as. Correct? Fine. What is the final velocity of the car? 0. Initial velocity of the car 100 square plus 2. A is the acceleration and displacement is what? 400 meter. Displacement is 400 meter. So from here, bring this on that side. 4 2s are 8. 800A is equal to minus, it will become minus, is it? 10000. These two 0 cancels out. Acceleration is minus 100 by 8. Correct? Which is minus 12.5 meter per second square. This is the acceleration. So if they ask acceleration of the car, your answer will be minus 12.5 meter per second square. But if they ask what is the retardation, retardation means the force or the acceleration which is what? Opposing the motion. This is the meaning of retardation in simple words. The force which oppose. So already this word contains the meaning oppose. So already it has taken negative inside. Retardation means what? Slowing down. So you have to understand retardation is negative of acceleration. So if acceleration is minus 12, retardation will be what? 12.5 meter per second square. So if someone says that retardation is 12.5 meter per second square, what you will understand? You will understand that this force, this opposing force or this retardation is slowing down the body by 12.5 meter per second per second. It means every second the velocity will decrease by 12.5 meter per second. So read the question carefully. Why I gave you this question? You know, in some questions they will sometime ask you acceleration. So suppose if you got acceleration, your answer will be minus 12.5. Sorry, sometime they will ask you retardation. You have to understand if acceleration is coming negative, remove minus, that will be retardation. Because the meaning of retardation is oppose. Clear? Okay, you can pause and write. Now come to third part, time in which the car came to rest. So now I want time. So I can use v equal to u plus at. I know final velocity 0. I know initial velocity 100. I know acceleration minus 12.5 into t. So from here 100 is equal to 12.5 t. So time will be 100 upon 12.5 and this will be 8 second. Your answer will be 8 second. I hope it is clear to everyone. So keep in mind retardation is negative of acceleration. Okay? Understood? Pause and write. Okay. Let's come to next part, which is average velocity of a particle, average velocity of a particle when acceleration is constant. Okay, so let's say we have a particle which is going with a speed u. The acceleration on the particle is a, it's a constant acceleration. After some time the velocity of the particle is v. So if someone asks you what is the average velocity, what you will say? See, we know that average velocity is nothing but displacement upon time, correct? When the acceleration is constant, what is displacement? Displacement is s is equal to ut plus half at square, correct? Let's say the particle has displaced by s amount in time t. Correct? So displacement will be ut plus half at square in what time? T time. Correct? So if you take 1t common, so t and t gets cancelled out and you got u plus half at. Correct? Now from here, can I write average velocity as, can I write u as u by 2 plus u by 2? U by 2 will be u plus half at. Correct? You can take LCM, which will be 2, u plus what you have? U plus at. What is u plus at? First equation of motion. What is u plus at? V equal to u plus at. So average velocity will be u plus at is v, u plus v by 2. This will be the average velocity of the particle. Clear? So when there is constant acceleration acting on the particle, average velocity will be u plus v by 2. Initial velocity plus final velocity divided by 2. Is it clear? Understood? You have to keep one thing in mind when, you know, like if acceleration is constant, it means velocity is increasing linearly with time. If acceleration is constant, velocity increase linearly with time. Not only here, anywhere. When the change is linear, to find out average, you can use initial plus final by 2. I will prove when I will teach you graph and all. I will show you there as well. Okay, when the variation is linear, we can directly do initial plus final by 2. But right now you keep in mind, when acceleration is constant, average velocity will be initial velocity plus final velocity divided by 2. Clear? Fine. Pause and write. Okay. Next question. A particle starts from rest. A constant acceleration acts on the particle, and particle move for 20 seconds. Or you can say at 20 second, here particle is here at time t equal to 20 seconds. Acceleration is constant. So particle starts with 0 velocity, acceleration is constant. After 20 second, particle is here. Okay, this is the first 10 second. This is the first 10 second. In the first 10 second, displacement of the particle is s1. In the last 10 second, displacement of the particle is s2. You have to tell me relation between s1 and s2. All of you pause and try. Acceleration is constant. Particle travel for 20 seconds. In the first 10 second, displacement is s1. Last 10 second, displacement is s2. Find relation between s1 and s2. Done? So what I will be doing, see, in the first 10 second, let's find the displacement. So s is equal to ut plus half at square. What is initial velocity? 0. So ut will be 0 plus half. What is acceleration? Constant a. And time is 10 square. So displacement of the particle will be 10 square 100, 100 by 250. 50a will be displacement of the particle. Correct? Okay. Now see, you have two ways. You apply s equal to ut plus half at square in the second half. Okay, but for that you should know initial velocity. For the second half, this is the initial point. You should know velocity here. You cannot take 0. So you can find velocity here, and then again you can use s equal to ut plus half at square. But what I am going to do, I know s1, this displacement I know. This I know. Clear? I will find out this total displacement. And from this total displacement, if I remove s1, I will get s2. So s2 will be what? S2 will be total displacement minus this displacement in first 10 seconds. Clear? So what will be total displacement? You will say sir, total displacement. For total displacement, I can take initial velocity 0. That's why I am doing that. So initial velocity will be 0. So ut will be 0 plus half. Acceleration is same everywhere, and time for total displacement is 20. Total time is what? 20 square. So displacement total will be 400 by 2, 200a. So displacement in second half will be total displacement 200a minus displacement in the first half, which is 50a. So what you will get? 150a. So displacement in the first half is 50a and displacement in second half is 150a. Divide both the equations. So displacement 1 by displacement 2 is 1 by 3. Yes or no? So displacement in last 10 second will be 3 times of displacement in first 10 second. This will be your answer. Clear? I hope you all understood. Pause and write. Pause and write. Done? Okay. Next problem. We have a particle at time t equal to 0. The velocity of the particle is 40, let's say 20 meter per second. The particle starts at 20 meter per second and acceleration is left, means opposing, which is 2 meter per second square. Clear? Here we have a point B, or let's say a point alpha. The point alpha is at a distance of 40 meter. You have to find time in which particle will cross point alpha. All of you pause and try. Pause and try. Done? Done? You know, whenever you are solving this type of question, I will prefer without thinking, write the equation, get the answer. And whatever answer you get now, from there you think on the problem point of view. For example, let's say this is this marker or this pen. If I throw the pen up, on the top fan is there. My question is, if I throw this pen up, in what time the pen will cross the fan? So if I throw the pen very fast, it will cross the pen once, and while coming back again it will cross. It will cross 2 times. Yes or no? But if I throw very slow, it will not cross. If I throw very slow, it will not cross the fan. And if I throw at a particular velocity, this is the fan, it might just go, reach and come down. If I throw very fast, it will cross once and again it will cross my hand. I am throwing, it will cross my hand once, second, 2 times. If I throw very slow, it will not cross. And if I throw at a particular velocity, it might go, just touch and come back. So it may cross 2 times, it may cross once, when it will just exactly go in front and come back, and it may never cross. So with the equation you will get the answer. If you write the equation and solve, if you get 2 time values, 2 real value of time, it means 2 times it will cross. If you get 1 time positive, 1 time negative, only once it will cross. And if you get both the times imaginary, never it will cross. I hope you are understanding. Okay. So if you look at this problem, to cross alpha, from here displacement should be how much? You will say, sir, alpha is 40 meter apart, displacement is 40. Right means positive. Correct. Initial velocity is 20 meter per second. Correct. Acceleration is left opposing, so minus 2 meter per second square. Time they are asking, I will use second equation. S is equal to ut plus half at square. So from here, displacement will be 40, initial velocity will be 20t plus half, acceleration is minus 2 into t square. This I will send there, so it will become t square, this also there, minus 20t plus 40 equal to 0. Let's find the roots. I hope you all know how to find roots. Minus b, so minus, what is b? Minus 20 plus minus under root b square. So b is minus 20, minus 20 square will be what? 400 minus b square minus 4ac. So minus 4, what is a? Coefficient of t square 1. A and c is 40. C is 40. So 1 into 40. So I can write this directly as 40 fours are 160 by 2a. 2 and what is a? A is 1. So what you will be getting? Time t equal to minus minus plus 20 plus minus under root 240 by 2. Correct? So you can see if one time will be 20 plus root 240 by 2 and one will be 20 minus root 240 by 2. Both the times are positive. You will get 2 times. You can just find from here t1 and t2. Once by taking plus, once by taking minus. At 2 times the particle will cross alpha. And you can understand also, I am throwing something right, but acceleration is left. So first this will slow the particle. So particle will slow down, come to rest, then particle will come back. So once while slowing down, it will cut, and once while coming back, when the particle is speeding up, again it will cut. So alpha will be cut 2 times. Clear? Sometimes you might get time imaginary, no real value of time. So in that case, you know what happened? This was alpha, this was particle. Particle was slowing down. Before reaching alpha, particle reversed direction and went back. It means particle never reach to alpha. So these things you can take care. Understood? Clear? Pause and write. So this question I have written already, okay, so that we can save some time. So the question is, a car moving with 20 meter per second, suddenly a dog came across the road. If the reaction time is 0.5 second, then what is the safe distance for driver to apply brakes if the car has maximum retardation of 4 meter per second square? So what is the meaning of this problem? First you have to understand, A driver is driving a car with 20 meter per second. He sees a dog in front of the car. Okay, now if you see something in front of, let's say you are driving a bike or cycle, if you see some obstacle, first you see, it's not like immediately you apply the brake. Your eyes will see, your brain will send the signal to your hand, then you apply the brake. Correct? It means a fraction of second is there in observing the event and reacting for that event. That time gap is known as reaction time. Very, very important. That time gap is known as what? Reaction time. I will prefer you all write reaction time is that time in which your eye see the event and your hand react on the event. That time gap. It's a very small time, but that time has to be considered while solving problem. Clear? So in this question, if you read, so car was going with 20, driver sees a dog, he applies brake, but the reaction time is 0.5 second. Means when he has seen a dog and his brain has sent him a signal that apply a brake, that has taken 0.5 second. So for that 0.5 second, for that reaction time, the car will go with 20 meter per second. All of you write. In reaction time, the velocity or whatever motion particle is doing will remain same, है ना? So velocity will remain same, that is what? 20 meter per second. Understood? Is it clear? What is reaction time? The time interval in which you see the obstacle and you apply the brake. Means you will see, then brain will send the signal to your hands will apply brake, or your leg will apply brake. There will be a fraction of time between that is known as reaction time. Clear? In that time interval, velocity will remain same, in this case 20 meter per second. So here was the car, reaction time 0.5 second. So for 0.5 second, the car will go with 20 meter per second. So how much car distance will cover? So this, there is no acceleration, the car was going with constant velocity. There is no acceleration for that 0.5 second. So how much distance car will cover? So distance you know, or displacement you know, velocity into time. Velocity is 20, reaction time is 0.5 second, which will be 10 meter. It means after seeing the dog also and before applying the brake, the car has moved by 10 meter. And now here the brakes are applied. And when the brakes are applied, it gives a maximum retardation of 4. I told you retardation 4 means acceleration will be, retardation is negative of acceleration. So acceleration will be minus 4 meter per second square. And what they're asking, then what is the safe distance for driver to apply brake? Means I have to find that distance. If the driver applies brake, the dog will be safe. So first 10 meter, the car will travel in that reaction time. And when he will apply brake, after this, the car will slow down and finally the car will come to rest. So how much more the car will travel, we have to find out. So from here to here, after he applied brake, I have to find displacement, I don't know. Velocity, so car was going with 20. In the reaction time also the car will go with 20. And when the brake will start to apply, initial velocity will be 20. And now as the brakes are applied, the car will slow down and come to rest. So final velocity of the car will be 0. What is acceleration? Minus 4. The brakes are giving an acceleration of minus 4 meter per second square. So what will be displacement in this second region? S equal to ut plus half at square, because acceleration is there. So you will write S is equal to u. Initial velocity will be 20. Time will be, you can also apply Vt minus half at square, better, because final velocity is 0. You can apply Vt minus half at square, same thing will come. Okay, I am using ut plus half at square. Time. Okay, displacement we have to find out. Time they have not asked, no. Time is not required, leave. You apply V square equal to u square plus 2s. Time is not there, so why to use S equal to ut plus half at square? Time is not needed. So finally the car will come to rest. 0. If they ask time, use that equation. Initial velocity of the car is 20. 20 square will be 400 plus 2. What is acceleration? Minus 4 into s. So from here what you will get? 4 2s are 8 minus 8 will go on that side. So plus 8s is equal to 400. So displacement is equal to 400 by 8, 50 meter. It means after applying brake also, the car will come to rest after traveling 50 meter. So answer will be what? Your answer will be 60 meter. The safe distance for the dog will be minimum 60 meter. If the dog will be 60 meter apart from the car, when the person sees the dog, then the dog will be safe. 60 or more than 60. So safe distance will be 10 meter. The car will travel in the reaction time plus 50 meter when the brakes are applied. Answer will be 60 meter. Very, very important. These questions can come in JEE Mains and NEET. Okay, the questions involving reaction time. Just keep in mind, reaction time is that time in which you see an event and you react for that event. The time gap between that. In that time gap, the particle follows the same motion. Here 20 meter per second. Clear? All of you pause and write. Pause and write. Pause and write. Done? Okay. Next problem. Next problem. Again we have a particle. On the particle a constant acceleration is acting. A. Clear? This particle, capital A, capital B. This particle crosses the point A. We have a particle which is going with which is being acted by a constant acceleration. When this particle passes in front of a point A, its velocity is u. And when the same particle passes in front of a point B, the velocity is v. See, acceleration is there, na? So velocity will continuously change. So when the particle is in front of A, its velocity is u. And when the same particle is in front of B, its velocity is v. We have a point C, and this C is the midpoint of AB. Midpoint of AB. Okay, you have to tell me the velocity of the particle at C. What will be the velocity of the particle at C? All of you pause and try. Pause and try. Okay. So what I have told, particle has a constant acceleration. At A velocity is u. At B velocity is v. At the midpoint of that, when the particle is at the midpoint, let's say its velocity is v dash. That v dash they are asking. That v dash they are asking. Both are same. Okay. So what I will do, let's say from A to B, displacement is s. So C is the midpoint. So this displacement will be s by 2. See, whenever you see a problem, you have to start working on that. When you start working, then you will get answer. Okay, just don't think what to do, how to do. Just write equations, you will get answer. So let's apply from A to B. So from A to B, I know displacement, I know final velocity, I know initial velocity. Use third equation. From A to B, use third equation. So V square is equal to U square plus 2AS. Final velocity, initial velocity, acceleration, S. Same you do for A to C. For A to C. So from A to C, final velocity is V dash square is equal to initial velocity is U square plus 2, acceleration is constant everywhere, and from A to C displacement is what? S by 2. Displacement is S by 2. Clear? I want V dash. See, displacement is not given. I have assumed. As I have assumed, I have to eliminate. Can I do one thing? Write this as V square minus U square is equal to 2AS. Correct? Absolutely correct. This one, V dash square minus U square is equal to 2AS by 2. See, 2 to cancel. You can write this as what? AS. Correct? Equation number 1, equation number 2. Divide both the equations. Divide equation 1 by equation 2. So what you will get? V square minus U square is equal to 2AS. Divide by V dash square minus U square is equal to AS. Correct? Cancel out. V square minus U square is equal to, send this on that side, V dash square 2 times minus 2U square. Correct? So from here, send 2U square on that side. So v square minus u square plus 2u square is equal to 2v dash square. So minus u square plus 2u square will be plus u square, correct? So plus u square is equal to 2v dash square. So from here, this 2 will come this side in denominator, and you will be getting v dash as what? You will be getting v dash as root of v square plus u square by 2. This will be the velocity of the particle when the particle will be in front of C, at point C. Clear? All of you pause and write. So what I did, I just wrote third equation from A to B, A to C. I just did some rearrangement. I divided, I got. Clear? Pause and write. Pause and write. Okay. Next problem. We'll do 2-3 more questions. Okay. One more question, then one question based on displacement in Nth second. Then we'll pack this lecture. Now in this problem, let's say this is a bridge. And this bridge is 700-meter long. Correct? Here we have a train, and this train is 100-meter long. This train is having an acceleration of 1 meter per second square, and when this engine of the train is just about to enter the bridge, the velocity is 10 meter per second. See, acceleration is there, na? So velocity will continuously change. The moment the train is about to enter the bridge, its velocity is 10. Acceleration is 1 meter per second square. Length of the train is 100 meter. Length of the bridge is 700 meter. Find the time in which train will cross bridge. So see, displacement is given, time is given, acceleration is given. So in my mind, second equation is coming. I think same is coming into your mind. Displacement is given, some distance, okay, means displacement, some parameters are there. Initial velocity is there, acceleration is there, time they are asking. So one thing I understood, S equal to ut plus half at square. But why I gave this question, you know? Listen carefully. Question is when the train will cross the bridge. This is the starting point. When starting point will reach here, when the starting point of the train will reach here, will the train cross the bridge? Answer will be no. Because when the starting point will reach here, the remaining part will be on the bridge. Are you understanding? So to cross the bridge, what should be the position of the train? You will say, so to cross the bridge, the train back end part, the last part of the train has to be here, and the front part of the train has to be here. Now you will say the train has crossed the bridge. Yes or no? The end of the train has to be at the end of the bridge. Then you will say the train has crossed the bridge. It means how much each part of the train has to travel. You pick any part. The entire train is connected. Na? You take this part, the starting of the train. How much starting of the train has traveled to cross the bridge? You will say the starting of the train is here, and finally the starting of the train is here. So how much the train has traveled to cross the bridge? You will say, sir, this part 700 plus the length of the train. So displacement will be 800 meter. That's why I gave this question, so that you don't do any silly mistake. Don't take the length of the bridge, or you can see the back end, the last part is here, and to cross it has to be here. So 700 plus 100, 800. Every part of the train has to move by 800 meter. So displacement will be 800. Initial velocity 10. Time we don't know, plus half, acceleration is 1 into t square. So what you got? 800 is equal to 10t plus t square by 2. You can solve this quadratic equation and you will get the value of time. Is it clear to everyone? Understood? Pause and write. All of you pause and write. Okay, let's move to next part. Next is displacement in nth second. displacement in nth second. Now what is displacement in nth second? See, let's say you have a particle. To make it simple, its initial velocity is 0 and the acceleration acting on the particle is 2 meter per second square. I am asking you some questions. Find displacement in 3 second, and second is find displacement in third second. You have to understand these two questions are different. Displacement in 3 second means displacement from 0 to 3 second, whatever the particle has displaced from initial time to the time when you are finding. Second is displacement in third second. What is the meaning of third second? This is second hand. 0 to 1, 1 second, 1 to 2, 2 second, 2 to 3, 3 second. So first question is this. Displacement in 3 second means in this total time whatever displacement particle has suffered. Second question, displacement in third second. Third second means this is second hand, 0 to 1, 1 to 2. When the second hand is going from 2 to 3, when the second hand is going from 2 second to 3 second, in that time interval, how much the particle has displaced, that is the displacement in third second. Clear? So first part, how will you solve? You will say, sir, very simple. S is equal to ut plus half at square for the first part. Okay, so s is equal to initial velocity 0, half, acceleration is 2, 3 second means 3 square. So you will get 9 meter as the displacement. Second question, how to solve second question? In second question I have asked displacement in third second. Third second means what distance particle has covered when the second hand was going from 2 to 3. So like this started 0 to 1, 1 to 2, from 2 to 3. So you will say, sir, do one thing, find displacement in 3 second minus displacement in 2 second. That will be displacement in third second. Yes or no? So displacement in third second is displacement when the second hand goes from 2 to 3, 2 second to 3 second, which means you can find displacement in total 3 second minus displacement is in total 2 second. If you subtract, you will get displacement in third second. Are you understanding? This is 0, 1 second, 2 second, 3 second. So in means total displacement, and in 3 second means total, and in third second means displacement from 2 to 3. When the second hand went from 2 to 3, whatever the distance particle will cover, whatever the displacement particle will cover, that will be displacement in third second. This is displacement in third second. So can I say one thing? Do one thing. Sir, you find displacement in 3 second. You find displacement in 2 second. So from 3 second, if I subtract 2 second, I will get displacement in this last second, which is the third second. Correct? Yes. So what to do? Displacement in 3 second. Ut plus half at square. Initial velocity is 0. Half. Acceleration is how much? 2. And time is 3. 3 square, 9. Minus displacement in 2 second. Again, initial velocity is 0. Ut will be 0. 2 second, na? Ut will be 0. Plus half, acceleration is 2. And this is 2 second means 2 square will be 4. So what you will be getting? 9 minus 4, answer will be 5 meter. Displacement will be 5 meter in what? In third second. If I say what is displacement in 9th second, you will say, sir, find displacement in 8th second. Find displacement in 9 second. Displacement in 9 second minus displacement in 8 second. If I say what is displacement in 17th second, you will say, sir, find, what you will do? Sir, find displacement in 17 second minus displacement in 16 second. Displacement in 44th second, you will say, sir, find displacement in 44 second minus displacement in 43 second. So what I am doing, if I generalize displacement in nth second. So displacement in third second, what you wrote? Displacement in 3 second minus displacement in 2 second. If I say displacement in 9 second, you will say displacement in 9 second minus displacement in 8 second. If I say displacement in nth second, you will say displacement in n second minus displacement in n minus 1 second. Yes or no? Yes, sir. So now you write displacement in n second will be displacement in n second. In n second, how much particle will displace? You will say, sir, apply the formula ut plus half at square. So let's say the particle has initial velocity u. Clear? So you will write displacement in n second will be u, and time is n second, plus half acceleration is constant into what? T square. This is the displacement in t. Time is n. Sorry, time is what? N square. Correct? Minus displacement in n minus 1 second. So here time is n minus 1. So ut. So time is n minus 1 plus half acceleration. Time is n minus 1 whole square. Correct? So what you will be writing here? The displacement in n second will be un plus half a n square minus, open this. So un, minus is there. So minus un. Then minus u into 1, outside minus. So plus u into 1. This one has a significance. Wait till the end. I will show you. Plus half a, open this bracket, what you will get? Okay, write it as it is, n minus 1 whole square. Clear? So you can see un and this un gets cancelled out. Correct? So displacement in n second will be, what I can write, u into 1, which is u, plus half a n square, half a n minus 1 square. You take half a common, you will get n square, and that will be, minus is there, no? This will be minus, sorry. This minus, if you open the bracket, minus n minus 1 whole square. I have taken half a common from here, half a common from here, half a. Here I got n square minus n minus 1 square. Is it a square minus b square format? What is a square minus b square? A plus b, a minus b. So you will get displacement in n second will be u plus 1 by 2a, a plus b. So n plus n minus 1 and a minus b, n minus n minus 1. Correct? This is what you will get. So what you can write here? You will see displacement in n second will be u plus 1 by 2a. See, n and 2n minus 1. 2n minus 1. N minus n 0 minus 1 plus 1. What is this? This will be n minus n plus 1. Na? So what you will get? Ultimately 1 you will get. 1. This is the formula of displacement in n second. If you remember, it will be really good, especially for NEET and JEE Mains. Displacement in n second is u plus a by 2, 2n minus 1. If you forgot, no issue, you have that method to find out. You know the fundamentals. I will find displacement in n second. If I say third second, displacement in 3 second minus displacement in 2 second. But if you remember, this will save your time. The formula for displacement in n second is u plus a by 2. U is the initial velocity, a is the acceleration, n is the second of which you are talking about. For example, in the previous question, what I have asked you, displacement in third second. So here n value will be 3. You can check. Displacement in third second will be, look at the previous case, the initial velocity of the particle was 0, acceleration was 2. Put here, initial velocity 0, acceleration 2 by 2 into 2n minus 1, 2. Which second I am talking about? Third second. So 3 minus 1, 2 cancel, 1, 3 to the 6 minus 1, 5 meter. If you check here also, what you got? 5 meter. Clear? Understood? One more thing, it's not like ki n should be 1, 2, 3, 4. No, n can also be 3.2, 4.7, 8.6. It can be any value. I have not told you ki n should be a natural number. No, they can ask you. I can ask you. Let's say a particle starts with initial velocity 2 meter per second. Acceleration on the particle is 1 meter per second square. I can ask you, find the displacement of the particle. Find displacement in 8.1 second. 8.1 second. Find displacement in 8.1. N can be anything. Okay, it's not like it should be one. It cannot be decimal. It can be. What is the meaning of displacement in 8.1 second? You can say, sir, I can use displacement in 8.1 second is displacement in 8.1 second minus displacement in 7.1 second. But instead of doing this 2 times, to save your time, you use the formula. Displacement in nth second will be, I am talking about 8.1 second. You will say u, what is the initial velocity? 2 plus acceleration is 1 by 2 into 2. Which second? 8.1. So n value will be 8.1 minus 1. You will get the answer. This is true for any time gap. The time gap should be 1 second. The time gap should be 1 second. It can be 8.1, 16.7 second, 19.4 second. All can be used. For all we can use this formula. Clear? Pause and write. Pause and write. Done. You know, now if you look at the formula which you got right now, S is equal to U plus A by 2, 2n minus 1. I hope many of you are thinking that so this formula is dimensionally incorrect. This is displacement. Displacement is in meter. U meter per second. And n is a number. This is overall a number. Number minus number is a number. This is number. Here we have A. What is unit of A? Meter per second square. According to principle of homogeneity, we can add or subtract only those terms which have same units. I can do kg minus kg, 10 kg minus 4 kg. I cannot do 10 kg minus 4 meter per second. Yes or no? So is this formula dimensionally incorrect? Answer is no. This is dimensionally correct. You know, that's why I was writing 1 here. If you all see, we have a 1 here. What was this 1? What was this 1? You all check u into 1. When you open this bracket, un minus u into 1 second. This was time. This was what? Time. So here we have a multiplication of 1. Are you understanding? We have a multiplication of time. This 1 is time. Time. Clear? In the same way, here we have multiplication of 1 square. You can check. I have missed somewhere. You can check. Just you find out. Here also we have multiplication of 1 square. You can see time is there. Time is there. Here we have multiplication of 1 square. It's 1 square. That's why we wrote as 1. And it seems like that this is dimensionally incorrect. But this is dimensionally correct. Dimensionally correct. Meter per second square into 1 square, which has dimension of time, which is second square. Here also we have a time. So this is also meter, this is also meter, this is also meter. All three has the same dimension. You all have to understand. This formula is not dimensionally wrong. This is dimensionally correct. Clear? You will think that so this is meter per second. But here we have 1. Here we have 1 square. While deriving, all of you please cross check. U into 1 I wrote as U. Here also we have 1 square. If you check, you will find out. It's your work. You find out. Is it clear to everyone? Understood? So this is dimensionally correct. Okay. Let's do one more question on this and then we'll pack this particular lecture. One last question. A particle starts with initial velocity 5 meter per second. And acceleration on the particle is 2 meter per second square at time t equal to 0. Find displacement in third second. No, not displacement. Find distance in third second. Let's change it. Find distance in third second. Pause and try. Pause and try. Now see. If you are using u by u plus a by 2, 2n minus 1, you will be getting initial velocity as 5, acceleration left, so minus 2 by 2 into 2 into third, 3 minus 1, sorry, 2 into 3 minus 1, you will say, sir, 5 minus 5, you will say displacement is 0. This is not distance, displacement is 0. Okay, so whatever this S gives you now, it's basically displacement. But what I have asked distance in third second. But what you have calculated, displacement in third second. Displacement is 0, correct? Displacement is 0. But distance, we cannot say. Distance and displacement are equal when particle move in a straight line. I have told you always, whenever you are solving questions of this type, always you check is the particle changing direction or not. Particle was going right, acceleration was left, so it will slow down and bring the particle back. It means particle is changing direction. In these questions, we have to be very, very careful. So what you will be doing, you will say, sir, first you find the velocity as a function of time. So v equal to u plus at. V equal to initial velocity is 5, acceleration is left minus 2 into t. Just you check where the velocity is becoming 0. Just you check. Okay, so I got to know 2t equal to 5. So t equal to 2.5 second. At 2.5 second velocity is becoming 0. Are you understanding what has happened in this problem? See, this is what they can do in JEE Mains and NEET. Simple question, but they can be a bit tricky. So it means at 2 second, if particle is here, at 2.5 second the velocity is becoming 0, and again at 3 second the particle is coming to same position. At 2 second particle is here, at 2.5 second the velocity is becoming 0 and particle is changing direction, and again at 3 second the particle comes back to same position. That's why you got displacement 0, but distance is not 0. The particle has covered distance. Very good question. Simple, but these questions can come in JEE Mains and NEET. Very important from Mains and NEET point of view. In advance, they might put this question in multiple correct options as one of the option. I hope you understood. So what to do? I understood, sir, at 2.5. See, if particle goes in a straight line, then you can say distance equal to displacement. Then you can use the same formula for distance also. But here particle is changing its direction. And the very important thing is the particle is changing direction in that time interval in which you are finding the displacement and distance. In which you are finding the distance. 2.5 second. You have to find distance covered from 2 to 3 second. If I ask, find distance in 4th second, 5th, 6th, 7th, your distance and displacement will come same. But as this is that time interval in which the particle is changing its direction, this time is lying in the time interval you are finding the distance. That's why the things are different. So what we have to do? What we can do? You do one thing, you find the displacement of particle in 2 seconds. So just check how much particle has moved in 2 seconds. So you apply S equal to ut plus half at square for 2 seconds. U is 5, 5 2s are 10, plus half, acceleration is minus 2 into 2 square. So displacement in 2 seconds will be 10 minus 4, 6 meter. So if particle starts from here, after 2 seconds, the particle is at what? 6 meter. Now you find displacement in 2.5 second. You will say, sir, for 2.5 second, it will be ut. So what is u? Initial velocity is 5, time is 2.5 plus half, acceleration is minus 2 into 2.5 square. You will be getting a 12.5 minus 2.5 square will be what? 66.25. So what you will be getting here? 12.5 minus 6.25, 6.25 meter. It means at 2.5 second, the displacement of the particle is what? At 2.5 second, when time is 2.5 second, the displacement of the particle is 6.25 meter. This will be 6.25 meter. It means at 2 second, listen carefully, at 2 second, the particle has displaced by 6 meter. At 2.5 second, the particle is displaced by 6.25 meter. So what will be this displacement? So you will say, sir, this is 6.25. This is 6. Are you understanding? Let me highlight this. So this is 6.25 in 2.5 second, and this is 6 meter in 2 second. So this is 6.25, this is 6. So this will be how much? 0.25. So you will say, sir, the displacement or this distance will be what? 0.25 meter. Again at 3 second, you check at 3 second, again the particle will have what displacement? 6 meter. You put 3, you will get 6 meter. It means particle comes back to same position. See the point where particle started at 2 second, then 2.5 second, again particle came back to same position. Na? That's why displacement came 0. You can put and check. If you put 3 second, na, 5 3s are 15 plus half minus 2 into 3 square. So 15 minus 9, you will again get 6 meter. And as we have checked right now, this is 0.25 meter. This is also 0.25 meter. So distance will be how much? See, displacement will be 0, 0.25 minus 0.25, 0. But distance will be 0.25, 0.25, 0.50 meter. This is the distance covered in third second. Very important. I hope you all understood. Clear? This was the last question. Again, I will explain you if you have doubt. When I was solving this question, I got displacement as 0. In that particular third second, displacement is 0. What does that mean? It means at 2 second, wherever be the particle, again the particle came to same point. The particle has not been displaced in third second. Or you can say at 2 second, wherever was the particle, again the particle came back to same point at the end of third second. It means particle has went and again particle came back. So displacement is 0, but distance will be there. And this happens only when the velocity becomes 0. And when I checked, yes, the velocity was becoming 0 at 2.5 seconds between 2 and 3. So between 2 and 3, the particle was changing direction. It means distance and displacement will be different. So what I did, I checked the position at 2 seconds. It was 6 meter. It was 6 meter. Then I checked the position at 2.5 seconds. It was 6.25 meter. So 6 meter at 2 seconds and 6.25 at 2.5 seconds. So displace. So from here the particle went 0.25 meter. 2 seconds. Let's say this is the initial point. So 6 meter at 2 seconds. Then it moves 0.25 in extra 0.5 second. Means at 2.5 second the particle is at 6.25. At 2 second particle was at 6. So displacement is 0.25. Again at 3 second particle came back. Again 0.25. So distance is 0.5. I hope it is clear to everyone. You can pause and write. Okay. So this was this for this particular lecture. In the next lecture, I will be doing motion under gravity and then we will do graph. Okay. So all the best. Just keep on studying. Be consistent. Do hard work. Bye.